Okay, at this video we are gonna talk about exponential the derivative of exponential function. Okay, see the last one we did, it is the correct one is like this: 2 over 3 minus 3 over 3. When we bring it down here, it's going to be positive. The negative is going to change if we bring it to this, and so that's the correct one. Okay. See, the exponential, like we have two kinds. Either you have e to the power of x. See, we know that when we draw this one, it's going to be something like this. E is actually 2.71 something, and it's 2.718 and something, okay? But it's just a number, like you write it because it has a lot of 2.82, 81, 82, 81. It actually is 2.71, 82, 81, 82, 80. It just doesn't never ends. That's we talked about it in those numbers. So okay, the derivative of these. What is going to be the derivative of this? Actually, the general formula for this is going to be y e to the power of u. Whatever it is, it might be x plus 5 or something. So what we do, the y prime or derivative is u prime times e to the power of u, and then ln e. See, since ln e is what it means is it is 1. This is 1 because ln e to the power of what is going to be e? E to the power of 1. E to the power of 1 is going to be e. Okay? So that's what we don't write it, but let's write it here, ln e. Now we solve this one, okay? This is the general formula. Y is equal e to the power of x. It means the u prime is x is 1. Y prime, which is the derivative of this function, is going to be 1 times e to the power of u, e to the power of x is u, and e, which is 1 times 1. So it's going to be the same. Actually, this is the only function that the derivative is the same is this. Now, what about if we have e to the power of x3, what is going to be? See, y prime is going to be x3. We get the u prime. This is u, so the u prime is going to be 3x2, and then we write times either this one or parentheses means multiplication, e to the power of x3, and then ln e, which is 1, so we don't write it. So this is the derivative of the exponent, and then you write exactly this one, e to the power of u, and that's it. So we can solve, we can write another example, and y is equal 8 e to the power of x 2x. Okay, what is going to be the derivative of this? See, the constant, we always write the constant. Okay, you always write the constant here, and then you have you write e to the power of 2x, and then the derivative of this one. Okay, see, we write e to the power of x. We write the constant, the coefficient just before that, and then times, this is e to the power of 2x, and then times what? The derivative of u is u prime is 2. So it's going to be 16 e to the power of 2x. So remember that the derivative of this kind of function pretty much the same as just exponential, number. If this one number here like 5 or whatever it is, it's gonna have the same like, see, if we have e to the power of x, okay, it's gonna be, it's gonna be like this, and like 5e, and you know that if you put a negative on there, it's going to be d here. And you know, you have the calculator. You can always find out what the graph is look like. Now we get back to this. We put a number here. We put a number here. We put 5 to the power of x. Y prime is going to be x. U prime is going to be 1. We write 5 to the power of, we write 5 to the power of x. We write the same thing, and then times ln 5, the base, and then this is the power. So actually, this is exactly the same as natural logarithm, but instead of e here we have the number. So this is very easy, and like, give you another example. Y is equal 3 to the power to x2 plus x. Okay, well, how do you do this? Y prime is going to be, the derivative of this is going to be, first you get u prime. U prime is 2x plus 1. Okay, and then you know all these multiplication, and you write exactly this one to the power of x2 plus x, and then you write ln 3, ln the base, ln 3. That's very simple. You just write the u prime, which is the exponent of the number, and then 2x plus 1, I'm sorry, 2x plus 1, and then you write exactly this e to the power of 2, the same as this one, the same as 3 to the power of x2 plus x, and then ln of this base 3. So there are many other things. It might be, say, of I don't know, minus 4 x x minus 2 over 3. Let's try this one, okay? Minus 4 times, times x to the power of minus 2/3. Now, or the same as minus 4x to the minus 2 over 3. So what you do here, by the derivative of this one is going to be, you write this one minus 4, and let's write the number here. I'm sorry, we were supposed to use numbers here, not the 5 to the power of x to minus 4 x3. So what is going to be, what's going to be the answer? Why the derivative of this? You write minus 4 here, and the derivative of this is going to be 3x2 minus 4, and then u, which is 5 to the power of x3 to the power of x3 minus 4x, and then ln what? ln of 5. ln 5. These are all multiplication. And this is the power of this. This is the power of x3 minus 4, x3 minus 4x minus 4x is the power of 5. The exponent is like this. Okay, that's enough for exponential function, the derivative of that, and we write, good, the light is right there, and I just don't want to write anything there. How about logarithmic? That was natural logarithm. Let's talk about natural logarithm of a function. See, if we have y natural ln, derivative of natural logarithm, derivative of natural logarithm function, okay, y is equal to supposedly ln x2, ln x2. See, what we do here is the rules, the general rules is when you have like this, y prime is going to be ln this x2 is equal to u, okay, we call it u. This is ln u, u. So it's going to be ln u. So it's so easy. Why? This is, you just write the y, the derivative of this is going to be u prime divided by u, and that's it. So see, ln u prime u. Okay. No, it doesn't have, it's just u prime over u. Okay, so what we do here, we have this, the derivative is going to be u prime, this is u, okay, u is equal to x2, in front of u is and u, so u prime is going to be 2x, and then you write u is ln x2. U is x2, okay, and then when you simplify 2 over x, okay, so just keep in mind that this is ln, this is u ln u, and then u prime over u, that's it. Now whatever it is going to be, now let's write whatever, x3 minus 2x minus 2 plus 3, what is going to be? So y prime is going to be, for this, is going to be u prime, 3x2 minus 4 plus 4 minus 2 is going to be multiplied by minus 2, and then minus, it's going to be minus, the exponent is going to be minus 1, so it's going to be 4x minus 3, and 3 is 0. This is u prime, and the u is x3 minus 2x minus 2 plus 3, okay? And that's simple as this. You get u prime over u, and that's the, how about see why we say ln x. What is going to be ln x? The derivative of this. The derivative of this is going to be u is ux, so it's going to be 1, and you write the x 1 over it. So the derivative of this one is this one, means y is going to be 1 over x. The derivative, that's why, you know, always we say the derivative of natural logarithm of x is 1 over x. Okay. So we don't need to, do we need to solve another example? Okay, yeah, just x 2 minus 3x. So it's going to, what is going to be y prime of this? It's going to be u prime over u, okay? U prime is going to be 2x minus 3, and then you write u2 minus 3x. You just read the whole thing. This is u, and the u prime is this one, 2x minus 3. Okay, now let's go to logarithm. See, this might, you might have this something like this, x minus 2 x2 plus 3. See, this is fractional. This is a rational function. So okay, let's see what's going to be the derivative of this one. This is a long. I will, because what you do, the derivative of this one times this one minus the derivative of this one times this one is going to be u prime. So let's do it. The derivative of this one is going to be 1 times x2 plus 3, and minus the derivative of this one is going to be 2x times x minus 2, and then x2, and then we write x2 plus 3 to the power of 2, and then these are just u prime, and then divided by u is x minus 2, x2 plus 3. What you do, you multiply this by this and this one by this. That's a long process of doing this. I mean, it takes time. So how about we talk about logarithm. Okay. Derivative of logarithm function. Logarithmic function. The derivative function. Okay. You have y is equal, is a general rule, log of, this is supposed to say a or b, for example, b u. What is the derivative of this? This is y prime is equal to this is u prime divided by u times ln of b, the base. You know what I mean? Okay, by example you find out what I'm trying to say. So let's write y is equal to log of 5, base 5, and this is x3. Okay, u prime, y prime is equal to, u prime is going to be 3x2, okay, 3x2 is going to be u prime, and then you write the u, what is u? U is x3, and then times ln of what? Ln of base, ln 5. See, these are very easy. You we are gonna just talk about so what is that? So this is, it's a u, you have expression here x3, u is x3, u prime is 3x2, okay, power rule, 3 comes behind it, and minus the exponent is going to be minus 1, 3 minus 1 is going to be 2, and then you write u here, and that times ln the base, b is the base. Okay. We can solve another problem here, another example, log of 5x3 minus 2x. So this is u, this is b, this is u, this is b, and the derivative is u prime is going to be 3x minus 2, and then divided by u, which is x3 minus 2x times ln b. What is b? B is 5. See, it pretty much the same as you know, the other one. So you can be, it can be exponent is radical x minus 1. So how do you do this? This u is radical x minus 1, which is x minus 1 over to the power of 1 over 2. Okay, so u prime is going to be 1 over 2 times x minus 1. 1 minus 1, 1 over 2 minus 1 is going to be 1 minus 1 over 2 times the derivative of this one, which is e1. So it's going to be 1 over 2 times x minus 1 to the power of minus 1 over 2. Okay. So if this is x4, let's see, x minus 1 over 4, like this one. U is equal x minus 1 over 4. U prime is going to be minus 1 4 times x to the power minus 1 4 minus 4 over 4 minus 1. We are talking about minus 1 here. See, we can write 1 minus 4 over minus 4 minus 1 is going to be minus 5. So it's going to be 1 over 4 x to the power minus 5 over 4. So u is going to be this one. Y prime is going to be equal to, and u prime is going to be 1 over 4 times x minus 5 over 4, and u is going to be x to the power minus 1 over 4 and times ln. ln is 5. ln 5. Okay? But you could write this one as this 1 4 here, and you can write this one times radical x5 4, because when it comes to denominator, it's going to be, the negative is going to go away, and then this one is going to come up, and then times radical x4 x1 in this is 4, and this is going to be, and then you can simplify this one, you know, if you have the division of you know, it's like 1 over 4 x to the power of 1 4 x to the power of 5 4. You know, that's going to be subtracted, and you know, you learned this before, and this is, you know, this is logarithm functions derivative and natural logarithm, and then we talked about the